Righto. My name's John Adams. I'm head of product at GliderBIM, and I'm going to tell you a little bit about myself and a little bit about the business, but not too much because that's not what we're here to talk about today. But I am going to be chairing this digital impact stage across the 3 days, so at any point you want to come and have a chat with me about anything, I'll be around here or just on the stand behind us over there. My career to this point, part architect, part software guy, part information manager. Been working around common data environments and data structures for the last few years, but this is Futurebuild and I'm opening the show, so I wanted to talk about things that aren't in my very specialist niche of information management. But before I get into that, Glider, who are Glider? I'm going to give you the shortest not a pitch ever. These are the logos of some of the customers that we work with, and when they've finished coming across the screen, I'll shut up and move along. But we do information management, we provide a common data environment, and we help people with digital transformation within their organisation and their projects. We work with clients, we work with contractors, we work with designers, and we just want to make sure everyone gets the most out of that digital journey. And I'll talk about that a little bit more as we go. But as I say, come and see us on the stand if you'd like to know more. So today's topic, why the future of construction is digital. And this is kind of the direction of travel that we're heading in. The world's changing, and we're going to start seeing a bit of a split in the industry between heritage skills and techniques, people who need to maintain what we already have, and this new world of autonomous digital enterprise. How do we use technology to really support what we do and supercharge what we do? You don't have to go to one extreme or the other. But the one place you don't want to be is sat in the middle, where you're not a specialist in maintaining what we already have and looking after our fabric, but you're also not taking advantage of technology. You don't want to get stuck in that middle zone, because there's going to be someone to the right of you or someone to the left of you who's going to win the work before you do. So either way, you're going to have to adopt digital, but it'll be a different journey. But digital's not really a transaction. You can't buy your way into digital evolution, adoption, and hoping isn't really a strategy. This pattern we've seen it fail. Hire some young, bright people, throw some kit at them, watch it fail. Doesn't really work. So what's a better approach? We take the digital tools and technologies that we're starting to see emerge, and we'll be talking about them on this stand throughout the whole show, and there's a lot of people in this hall who have some great technology with them. And we point those technologies at the challenges that we have. And there's lots of people out there doing that, but they're very quiet. They're not telling people about it, so I'm going to try and shout about it a little bit today. So some of the opportunities. How do we use technology to prioritize what we build and where we build it? What we're doing about new materials and eliminating waste. Big subjects in the industry. How do we use digital to mitigate skill shortages? And how do we meet the demand for smart buildings, which is starting to grow? All along, we're trying to move towards net zero. So there's some really big challenges here. Digital isn't going to do it alone, but it's definitely part of the problem. Part of the solution. So first thing, what do we do about buildings? Where do we put them? Why do we put them there? Infrastructure the same. Historically, we got a bit lucky. We built some fantastic structures that we've been able to reuse. So half the old banks in the country are now trendy wine bars, and they're doing a really good job with high ceilings and beautiful woodwork. But that's not our only legacy. We've also got things like this. Sunderland Civic Centre. It's earmarked for demolition because they want to put housing on the site and they've moved the council elsewhere. But that decision is being taken within the realms of Sunderland City Council. How are they considering the wider North East? How are they considering the Northern Powerhouse? And how are they considering the UK? The truth is, without good data analysis, it's really hard to look at all of those things in the round. So each of our cities and councils are making decisions based on their own needs. So we could lose a good building, still structurally quite sound. That could be a data center. It could be something else. but we haven't done that analysis to understand what we do with a building like this, so we're going to knock it down, put houses on it. It might be the right thing to do, but there might be another way that we haven't been able to work out. We haven't done the analysis. And then we've got buildings that we know we can't bring them all down, certainly can't, but we know they've got trouble, like Grenfell Tower and others that have similar issues that brought about the disaster. What do we do about those buildings? We don't even know where they are. When this happened, people across the country went looking through their portfolios to understand, do I even own one of these? It was a really big challenge, and it took months, years in some cases. So where does digital fit into some of this? One thing we can do with digital is throw some of the new technology in to really understand our existing estates. So the image on the left, that is a thermal drone of a roof. How's this roof performing? Is this roof worth keeping? That one's not too bad, actually. The windows could probably do with a little bit of work, but in general, not bad. The one in the middle is a piece of technology called Wave Scan, which most people haven't heard of. And it is a cross between a traditional scanner looking for pipes and wires behind a wall and a microwave system that can detect cracks in buildings. We can do thorough structural analysis of buildings without breaking the wall. We don't have to open them up. And if we put all that information together into our models, we capture that using BIM, using the UK BIM framework, using those processes to build good quality asset information models, and we keep them up to date, we'll understand our fabric a lot more. So in terms of our first challenge around what to build and where to build it, big data analysis. Can we understand our country better? What does each region need? What does each city need? Can they work together? Can we understand our need outside of those remits of civic centres and councils? Do we need to rethink the regional megacity approach which we've been moving towards? Post-pandemic, does everybody want to move into a regional megacity? That was definitely the pattern. Northern Powerhouse, supersized Manchester, supersized Newcastle. Do we need to? I don't think we've got the data to make that decision yet. I think we need to pull that data together, analyse it. There's a lot of algorithms that we can throw at this that we haven't done it yet, but people are doing it. Can we improve our digital connectivity to make sure working from home is a little bit easier? It's been good for some people, bad for others. At Glider, we've been digital since day one. We've been remote since day one, so we're all well set up. But a lot of businesses have moved to working from home very quickly. What can we do to support that, make that easier for people? And ideas that we've seen in the Middle East. Social media for public consultation. Rather than sticking all the plans in the basement of some public building, get it out there, get those comments back and capture people's actual opinions into the process, build the right things in the right places. We all see when something big and contentious goes on, social media is full of people making comments, and then anybody suggests you might want to go to the public consultation or put a letter of objection in, no one can be bothered. There's a disconnect there between the technology people want to use and the process we have. Using the models that we're building, we're creating great federated 3D data-rich models. Almost as a matter of course, not on every project, but a lot of projects now have good information. And then when we put it in for planning and building regs, we take a 2D cut and we put the plans in. We're not using what we're creating. And then that ability to scan and digitize what we already have to understand whether that civic centre could be a data centre, or do we need to bring it down and do something else? We need to start using the technology that's available to us, but these technologies aren't widely known, aren't widely adopted yet. Okay, challenge number 2. What can we do about new materials and eliminating waste with digital? Anyone who's bought a sheet of plasterboard recently knows that traditional materials are getting out of hand. Cost and availability, it's ridiculous. I know the trade aren't paying £10 a sheet, but they're still paying a lot more than they want to. And we can't get rid of traditional materials, and nor should we, because we have traditional buildings. We have houses to upkeep, we have existing fabric to upkeep. But for new builds, should we still be considering putting wet plaster onto plasterboard? You can't move it without bringing it down. It's not the best idea. We kind of fall into specifying it because somebody drew a wall, and then we get through the process and go, oh, we didn't price for something innovative, we priced for plasterboard. And you get to site and you're stuck with it. But we've got some great technologies. 3D printing used to be the preserve of academia. Now we're seeing concrete printers that can be brought to site, produce highly accurate wall placement and component placement, and they can now be based on those BIM files that we're creating rather than having to be post-processed into a specialist thing that goes through the university and pops out as a trial project that runs alongside our project. Now we're in a position where we can use our own data. So draw it right, capture it right, but you've got to draw it with this in mind. So we've got to start designing with this in mind. Zero waste. Anything that doesn't get used goes back in the hopper. It's genuinely zero waste. And that's just concrete printing. We've got some really other fantastic uses for 3D printing in construction. This one caught my eye from Zurich. This is a foam formwork that you print, and you can either leave it in place as a very good insulation, or you can pull it back out again, chop it back up and use it again. Infinitely recyclable formwork. Now we just pour the concrete on the top of it. So we use less concrete, we reuse our formwork. It's a fantastic design that allows us to create beautiful patterns in concrete. So it's not all about we need to move away from our traditional materials. How do we use our traditional materials in a better way? And then bioplastics. Bioplastics are a fantastic idea. This is naturally produced plant-based plastics. There's quite a lot of them on the market now. How to use them, how to get involved. The Dutch are masters at it, we're not yet. But it's only across the water, it's not too far. And you can combine that with 3D printers and BIM models to really bring these into our design processes. Great material. Lots of using plant sugars to create plastics. Incredibly intelligent, but there is a watchword. Not all bioplastics are created equal. Please be careful with your specifications. Some of them are made out of live shrimp. Some of them are proper plant-based sustainable materials. So please do have a good look into that before you specify. And design for manufacture and assembly. Talking about it in the 1920s, Corbusier thought this was the way to do it. We didn't really get off the ground as much then because the quality wasn't there. But what he was trying to do was replicate the things they were already building, but off-site, in panels. Design for manufacture and assembly is a different mindset. You use that mindset to make sure what you're designing can be manufactured easily. And once it's been manufactured, it's easy to assemble. So you're thinking of those two separate processes, same acronym, but two separate processes. How do we get the thing built perfectly, right size, completely airtight, exactly what we wanted, then we bring it to site and the red bit goes with the red bit and we put a bolt through it. It's fast. It's easy to assemble. The quality is being proven by companies like Bride & Wood and Lang O'Rourke. It's there. We've got this in hand now, but again, if you don't start designing this way, you don't get this result. It's hard to change horses while they're moving. There is less waste because we only produce what we need. The efficiency of site logistics. Not just taking time out of the build, adding safety into the build. We're not moving things around. We're not going to hurt people. The parts should be self-aligning because they should be designed that way. That's the assembly part. That's the A in DFMA. That often gets forgotten. Everyone thinks about manufacture, but it's about making sure these components actually fit and someone can put them together easily. And the improved safety of this technique, it's remarkable how much safer our sites are. When we've planned it, we've built it with this methodology. It's a great way to go. So that is materials, digital materials. There's quite a lot going on there. Skill shortage, and this is one of the big problems in our industry, and a bit of an age test for some of you. It's not about mud. People for years said, young people don't want to join our industry, women don't want to join our industry because it's dirty and it's smelly and it's not very nice. That was a crap excuse then, it's a crap excuse now. That's not why people didn't want to join our industry. They wanted a rewarding job that was safe and they had a career path, and we weren't providing it. Digital allows us to create pathways in our industry that are genuinely interesting, genuinely safe, and have genuine transferable skills. Robotics. A career in construction robotics is one of the most exciting careers you can have at the moment. When I go into schools and I talk to people about construction robotics, lights go on around the room. Kids want to come and do this. And this could be designing a robot itself so it can do autonomous tasks, overnight surveys, that kind of thing. Or you can be sat working from home, driving the thing around, moving things around the site. You don't actually have to be on site to control the movement of materials anymore. Fantastic careers, new careers, interesting ones in our industry. And this is where we need to get into this mindset of autonomous digital enterprise. Our businesses always resist automation. And we've got to remember a couple of things. If a robot can do it predictably and successfully, that shouldn't be a satisfying job for a person. That's a boring job for a person. I watched a program the other night and there was two ladies. One had been working in the factory for 20 years, the other one for 30 years, and all they'd done for 50 years combined was taste beans 3 times a day to make sure the quality of the beans hadn't moved. Dear God, give it to a robot. Please. Yeah, these are the kind of jobs that stop people want to go into your industry. They see those roles and go, no thanks. I might get stuck in a job like that. I don't want to do it. So it's not about removing surveyors and putting robots on site. The value of the surveyor is not because he can use a tape measure. Anyone can use a tape measure, but the value of that knowledge. What is the impact of how far the works are on? What can we do with that particular site? What are the logistics? What are the opportunities? That's where the people fit in. That's where the interest comes in. Let the robot walk around and measure things. It can, and it can do a better job. Okay. So I haven't solved the skills shortage, but I think digital's going to help. Smart buildings and digital twins. This is a really interesting area of our industry right now. There'll probably be a lot of people talking about it over the next few days. And you'll see both sides of this coin across the event. People saying, stop talking about digital twins. We haven't cracked BIM yet. No, I've got problems getting models coordinated. I don't care what's coming next. And other people saying, it's actually really exciting. I want to know what's coming next. How do we make sure smart buildings and digital twins are secure, they're safe, they're valuable, they can be trusted, they actually deliver the promise that they're there for? People are confused, but we're starting to see the case studies. The Edge in Amsterdam, Deloitte are one of our customers, but this wasn't one of our buildings. This building is a fantastic building. It all came about the phrase, het nieuwe werken, Dutch for the new work. Probably a little bit easier for us as a new way of working, but that's the way they say it. And this building, it knows your schedule, it knows your calendar, so it knows when it needs to give you a desk, it knows when to give you a meeting room. It knows when you're traveling to work because your device is heading towards the office. So it can set your part of the office to the temperature that you asked it to. There are so many things in this building. The lights are so energy efficient that they run off the Ethernet cables. So this thing is a work of modern technological art. It's not a digital twin, it's a smart building. And there is a difference there. But this sets the prototype for what smart buildings should be. And we're working on a number of buildings that are taking inspiration from this and doing other things from this. But this one is a bit of a groundbreaking building for us. It's carbon positive. It creates more energy than it uses. If an alarm goes off in the evening, a little robot trundles along there with a camera and shows you what the problem is. So no one has to drive out to site. This thing is fantastic. So spend some time. There's some good videos on the internet about it. Really do get into it. But as I say, not a digital twin. Digital twins are still a little bit in the realm of academia. We're working on them now. We've got some live projects where the digital twin is the ambition, but handover's 2024, 2025. We're still working through some of those data structures and things. But this is the important thing to remember. It's not as complicated a concept as people try and tell you it is. If you have a building that is connected to the internet via sensors and it's providing information about itself, and you have a digital representation of that building, and you can bring the information you're getting from the building, overlay it onto your digital representation of the building, and get some new information that you didn't have before to make decisions, you're into the world of digital twins. That might be one process. It might be 40 processes. Are you turning off the right lights at the right time? You know, if I amend this bit of kit, what's it connected to and whose life do I ruin by turning it off at 12 o'clock on Tuesday? These are the things that are really hard to work out, would take days of going around asking people questions. You can take the data, look at the model, do a little bit of a prototype and say, if I turn that off, all of those desks don't have lighting. How many people are going to be in the building? We know from the schedules, the building already knows. Great, we can put them somewhere else. Turn that floor off, turn that kit off, fix the thing, everybody's happy, everything's fine. That's the world we're moving towards, and all of the technology is there. What we haven't got a really great handle on yet is how to design these, to get them into the process. Our plan of works doesn't consider a lot of the technology you need for a smart building or a digital twin early enough. We get to stage 4, start looking at the detail of the mechanical kit, too late. So later on tonight, on this stage, we're having a drinks reception where I'm going to be talking to some of my colleagues from we've been working together on a digital plan of works overlay. So it sits over the plan of works to say, if you're going to go on a smart building journey, you don't want to start thinking of these things at stage 0, stage 1. You know, so it's an overlay. We're not replacing the plan of works, but it's there to help you augment your project to create a smart building. And we will have beer and wine and things, so please do come back at 5 o'clock. And this is something that we're getting really deeply ingrained into at Glider. We've got some fantastic clients, projects who have different elements of this. And we're starting to see how difficult this is. You're going to have a BIM team trying to create an asset information model. You're going to have a smart building technology team trying to work out your sensor networks. How do you color code your sensors so you don't lose them? How do you bring those two pieces of data together so a sensor knows what space it's in? Sensors are brilliant, they're cheap, they can record things, but they don't know where they are. It can tell you how much CO2 is in the room that it's in, doesn't know which room it's in. So you've got to bring the model into play, and the model knows about the sensor. And then you can bring the data together and understand it. It's layering up of analysis. But there's a lot going on, and these are just some of the challenges that we're encountering, and we're working with our customers to help them on that journey. And we're starting to see the idea of relational databases fall apart at the seams a little bit when you get over the operational line. We need to deliver the relational databases because we're not going to get that information in the graph format from the subcontractor teams. That's not feasible. People aren't going to sit down and create this information independently. That's got to be the work of a data specialist or a master systems integrator. So we need to connect the information we're capturing, our O&M information, into our smart building realm. And we've been working with a number of customers to take them through this journey, which we call the information value chain. First step of that, what information are you going to need to meet your ambitions with this building? Is information about type level enough, or do you need to go to component level? How deep do you need your data to be, and what attributes do you need to collect? And once you know that, you need to tell people that. This is where we've fallen down a lot. Employers' information requirements or exchange information requirements, the tome of all the things you might possibly be able to deliver. If you hit one, give it to me. No, get rigorous. What do you actually want? And then when you've told people what you want, and you start getting data back, where are you going to put it? You've got to put it somewhere that's useful, it's secure, and you've got to make sure that information's actually right. Then once you've got good information, how do you connect it to your other systems? That edge building in Amsterdam, that's about connection of information. Where they haven't gone next, in terms of digital, is that analysing and evaluating what they have. They're not overlaying technology onto that. They're creating a dashboard and let people make the decisions, which is fine and it's brilliant. It's actually a fantastic team who are running that building, and they've got better information than they've ever had before. But the building's not suggesting anything. It's not saying you might want to consider turning the lights off on a Thursday afternoon because no one's there anyway. People are having to analyze the data. But we have machine learning. We have a lot of new technologies in other sectors that we can bring to this challenge of, we've got the model, we've got the structured data, we've got the sensor data, what's it telling us? Do a lot of this in medical. And then once we've got some good information, what do? Do we refurb our building? Do we make adjustments? Do we fine-tune things? Do we knock half a degree off something? It doesn't have to be big changes, but we can move the needle in terms of these smart buildings. So yeah, we're really in an interesting place with smart buildings. We're getting there. So rather than being in camp, don't do them yet, the skills aren't there, get excited about them. And if you're at stage 0 of a project, are there opportunities? It might be one user story. We'd like to know more about CO2 levels in bedrooms. That might be all you care about. Plot that out. What sensors do we need? What information do we need? How do we analyze it? Just go on this journey, go through the information value chain. And the important thing along the bottom, learn and improve. There's no harm in changing your information requirements if the information you got didn't support the activities you wound up doing. Go back, revise things. And the final part of the puzzle for me today, where digital could fit in, achieving net zero. Digital has a big part to play because mitigation is better than adaptation. We need to get ahead of the challenges. What can we do to mitigate the impacts of climate change rather than react to them when they happen? So we've got some fantastic technologies. Researching for this slide deck, I hit things I'd never heard of before. The big picture, that's a smog-eating facade. It takes in city smog and releases oxygen. It works like a tree. It's a fantastic bit of kit, but I knew that one, that was brilliant, and I thought, I'm going to talk about that. What else is there? And then I discovered this one just up the road, the little block of CO2. That's from Cambridge Carbon. They're working with Dudley Tiles and Tarmac. They fitted a carbon capture machine at the top of the chimneys at Dudley Tiles. They capture all that carbon and through a really quite simple process, turn it into a solid material, which is fireproof and safe and a very, very good carbon sink that Tarmac are using in block work. So we're just feeding one factory with another. It's a fantastic process. It means we're capturing our CO2 and we're using it to build new buildings. So the same as reed beds, the same as barrier reef, that idea of a carbon sink, integrating that into our cities, it's there. We're just starting to scratch the surface of this, but we're in a really interesting space for how we mitigate climate change rather than adapt to it. Okay, that was all of the things I wanted to talk to you today about. We've got a whole panel of fantastic speakers coming up on the stage. We've got about 15 minutes before the next gang come on, so please do come back and have a wonderful Futurebuild. Thanks, everyone.